Just before releasing the hotly anticipated GPT-5, OpenAI silently released two open-weight models. This marks a major shift in OpenAI's stance toward open source, since their last similar release was GPT-5 in 2019. The two models are called GPT OSS 120B and GPT OSS 20B, marking their respective sizes. Open source is extremely important for AI, just the way it was for software development in the past 20 years. Why? Because it drives adoption. We wouldn't have seen the exponential growth in tech all those years without open source libraries, frameworks, and more. By the way, in the center of this is a company called Hugging Face, and right now they host almost 2 million models of any kind of capabilities and sizes. This is something that we'll discuss pretty soon in another episode. OpenAI put a serious effort into raising the bar for open source. But first, I have to say that we are talking about open weight models, not open source. In a nutshell, the difference is that with an open weight model, you can access the pre-trained parameters, not the source code. This is a standard practice for major labs, so nothing new here. More importantly though, the GPT OSS models come with a very permissive Apache 2.0 license. This is a little bit in contrast with Meta's Llama and Google's Gemini open weight models, which come with custom licenses. So Apache allows for free commercial and non-commercial use. This may be something pretty important for your project. On the more technical side, GPT OSS do not offer multi-model capabilities because they are trained on a corpora of English-only text that's focused on STEM topics and math reasoning and, of course, general knowledge. Nonetheless, you can expect them to perform pretty well on standard NLP tasks and text generation and also question answering. The OpenAI's own evaluation points that the bigger model performs just as good as the commercial O4 mini model, depending of course on the benchmark, and the smaller 20 billion parameter model performs on par or even better than the O3 commercially served model. So this is pretty impressive. The hardware efficiency of both models is quite impressive for their size. The bigger model can fit on a single 80 gigabyte GPU, and the smaller model is meant for on-device use cases and can fit a 16 gigabyte GPU. OpenAI achieved this by optimizing their training process with quantization to the MXFP4 format, which allows for a 4:1 compression, and it's a relatively novel technique. They also used, by the way, their own Triton programming language that optimizes NVIDIA kernels also quite efficiently. It will be interesting to see and compare this to Apple's foundational models, the smaller GPT OSS to Apple's on-device model, even though they differ in size substantially. But Apple actually, they used a 2-bit quantization-aware technique here to be able to fit the model on iPhones. So I am personally very curious to evaluate the accuracy trade-offs here. Another interesting question is that OpenAI put a lot of effort into the safety of their models, specifically in the field of malicious fine-tuning, and even more specifically into the fields of biology and cybersecurity. This is a new field that evolves rapidly, paramount for the safety of everyone, perhaps, and it's another interesting thing to watch. Driving adoption is one big thing, but there is so much behind it. You need to win the developers' hearts. They need to be building on your platform, and it needs to be cheap. OpenAI's move to release their first open weight models is a direct response to Meta's grant initiatives that, by the way, already generate more than $70 billion in capital expenditures per year for Meta. And those models, they are very capable. And it raises the next question. AI, commercial AI served at API endpoint, isn't it getting commoditized already?